Hello, everyone. This is Matt Hoos with Rata Green, and I'm here with Eric Flower with Net Energy Optimizer. And met him at Greenbuild this year, and he was one of the software presenters where they showed how their software can make buildings more energy efficient. So he was kind enough to join us today to give us an overview of how their software works and how you can use it on your projects. All right, Eric. So tell us a little bit about how Net Energy Optimizer works. It looks like you guys call it NEO for short.
Yeah. Well, first, thanks for having me on. It was good to meet you at Greenbuild, and I'm happy to see you again here in the new year and get a chance to present our software to you. So I appreciate the opportunity to do that. Yeah, you're right. We do call it NEO. NEO is short for Net Energy Optimizer. It is a web-based energy modeling software, and it's really designed to provide customized energy modeling for architects, engineers, product manufacturers, utilities, and building owners to help make decisions for higher performance buildings. So I have my website up here just to kind of give that as an intro, but I'll jump over to the tool here as we get into the demonstration. I would like to note that NEO is really intended to model commercial buildings, mixed use, and multifamily. And it can support projects that are as small as 5,000 square feet, and there's really no upper bounds to the size of the building that you can model. As I mentioned before, typical users are architects, engineers, product manufacturers, building owners, and utilities. There's a number of different analyses that are available in the NEO tool. For each of those users, as they may all be looking at their building from a different perspective and what kind of analysis might fit them individually. And so we'll get into how those different users can navigate NEO in order to perform those calculations for their specific needs here in a few minutes. But really, in all cases, NEO provides a fast and validated tool for informed decisions during design to help construct and maintain and operate buildings that are high performing. So I'm going to flip over from the website here to the NEO tool. And what you're seeing now on the screen is really the beginning of the building definition page. At the top here, you can see we've got a location. This project is modeled in Atlanta, Georgia. It's 150,000 square feet. There's some functionality within NEO as a user to manage the building on this level. So if you have multiple users within your office or firm that's using the tool, you can see this little silhouette here. You can share models between folks, give them different levels of access, whether they can look at it from a read-only perspective or giving them full edit capabilities. So just a couple of things from the building level perspective here that allow for some administrative work on the project itself. A couple of things to note here. I do have underneath the buildings now we've got some defined projects. NEO can really be used to perform a specific analysis, or it can also be used to define number of projects. Maybe your building starts through early conceptual design and you've done some work there. And as that project evolves or goes through the design process into construction documents and then ultimately construction and operation, you can also carry projects forward from very early design all the way through operations. So you can really do it either way. You can kind of carry one through, or you can just come in here and define a building and work on a specific snapshot in time as well. But it really does offer both of those features within the tool. I defined a couple of different projects here to go through, Matt. I'm going to start down with the bottom one here, which is an HVAC system comparison. Users of this type of analysis or a life cycle cost analysis would typically be an engineer that's looking to do an HVAC comparison or product selection or HVAC selection type of analysis. Maybe they want to look at something before they put pen to paper to save themselves design time and cost. They can perform this HVAC lifecycle cost analysis and present it to their clients and try to give them an idea of which system may be the most efficient for their building going forward. Another main user that we see for the HVAC lifecycle cost analysis would really be product manufacturers, maybe a VRF or a boiler or a chiller manufacturer, a rooftop unit manufacturer that is looking to compare their HVAC systems with others that are out there on the market. We have a couple of different ways that we can do that, including product libraries where we can work with that product manufacturer and actually input things like your system name, the specific efficiency curves, your product pricing, so that your sales team can go out and use that and pull from the product library and show your exact units in a customized way to that building owner. So I'm going to jump into that HVAC lifecycle cost analysis, and then we'll come back here to this page a little bit later and look at these other two projects, which are rating analyses, a slightly different calculation within the tool. So as I jump into the project and I click the Launch Analysis button, that's going to bring me to this kind of initial landing page. Within NEO, there's a similar structure between our analyses. In that, at the top here, you can see we define the building, define the HVAC. In the HVAC lifecycle cost analysis, we have a financials tab and then a comparison tab. In other analyses, we kind of deviate here on these last steps, and we'll see that here in a few minutes. But as we are in the lifecycle cost analysis tab, this is the workflow for this type of project. You can see here as we go through the building definition that this is an office. It's about 150,000 square feet. That's kind of the global building definition. Once you've made that definition, then you can come in and start doing some customization to your project to match it up to your building specifically. And so if I click in this Modify Details button, you can see that we've got the option to come in here and define some facility level details as far as exterior lighting, elevators. If you're in Minnesota like myself, snow melt slab area, you guys probably don't have to worry about that too much in Georgia. But there's some options in there for that. It's something that we do see in colder climates. Down below on the building definition a tab here, we've got these space asset areas. And so these are really kind of defining the specific use cases that are within your building. You can see I've got two of them here, an office and a cafeteria. And these gray boxes here, we call those pods. Each pod you can go in and make specific edits down kind of the next layer and next layer here. So if we jump into the office pod by clicking the edit button, you can see that I've got some additional details here now that I can choose from. You can select multiple space assets. So if you've got an office that has a cafeteria and a data center and some other specific type of space, you can simply come in here and add and choose and kind of pick and choose and combine those to make your building in its entirety. In this case, I've really just done kind of a simple project with an office and a cafeteria. Within these pods, I can even come in and click Modify Details and go one level further. This is going to allow me to come in and define that specific space's characteristics. And so you can see here we've got operational, mechanical, architectural, lighting, and service water heating load details to edit. As I scroll through these, you can see that in the operations tab, I'm defining things like my people density, my building schedule, how many hours per use that space is receiving, when it starts, how many fan hours throughout the day, and those kind of variables. On the mechanical side of things, now we're defining thermostat set points, occupied, unoccupied, ventilation requirements, and so on and so forth. Architectural, this is where you're coming in and defining your geometry. The tool has a couple of different options here. If you are very early in conceptual design and you don't have a geometry, you can go with the default option. What that's going to do is it's going to use an algorithm in order to create a typical building shape for the building type that you've selected. If you do have building geometry, you can come in here and create that geometry. There's a lot of different options here to kind of get yourself off on the right foot with the building shape. And then you can come in here and segment, drag, drop, slide walls around, define the length, height, window to wall ratio, and those kind of things, as well as rotating the building here to include that azimuth. In the analysis, in the HVAC lifecycle cost analysis, we're also giving some additional information here on the upfront portion of this for the wall and roof construction, infiltration, and any fenestration that will be in the building as well. From a lighting perspective, again, defining your lighting power density and any lighting controls, whether it's nighttime sweep, timer sweep, no nighttime controls, or daylight harvesting, if you have or don't have them, and the specific control type and how much of the building is controlled by that daylight harvesting controls. And then finally, power and process loads, so things like plug load, kitchen equipment, service water heating. That's what you would define here in the service water heating and other loads. I'll say that one of the efficiencies that are built into NEO is really its ability to bring in these default inputs for the user. And I'll show you this. I should have hit it a minute ago, but I jumped right into the analysis. NEO supports a number of different energy standards. So it has ASHRAE 90.1 2004 all the way up to ASHRAE 90.1 2016. So 4, 7, 10, 13, and 16. When we get to 16, we also have started including both the Appendix G and the ECB type of measures. That's for engineers and folks who are following energy codes, they may know that there's been a shift in the energy code recently, and so now we're supporting both the Chapter 11 and the Appendix G calculations. But when you come in and build a model, you're going to select your energy code year, and that's going to help populate some of these inputs for the user, just to kind of give them a nudge in the right direction and make sure that you know, they're selecting and using valid inputs. The user also has the ability to come in and override that information. So a good example of that is the office. This people density value is coming from ASHRAE standards. So you could come in here, if you know that you're going to have a very highly occupied building, you could come in here and up that to 250, or if it's going to be low occupancy, you could drop that down to 150. So it gives you that information as a kind of a starting point to help you get through the model, but you have the ability to override all of that information as you need to. So once you've completed your building definition, then you can jump into the HVAC tab here. Since this is looking at that HVAC comparison now, you can define up to 3 different HVAC systems. So if we kind of think about ourselves as maybe a VRF product manufacturer who's trying to speak to a building owner about why they should go with a VRF system over maybe a cheaper packaged rooftop unit or a more complicated, you know, VAV chiller boiler system. This would be one use that that type of energy modeler could use in order to make that case. And so with that, I've defined 3 HVAC systems. Scenario A here, which is this blue dot, is a VRF system. And typically the layout for our HVAC tabs are the plant definitions are located here at the top, and system level definitions are here at the bottom. So at the top here, you can see I've got no boiler, no chiller, because it's a VRF system. I have defined a dedicated outdoor air system that's bringing in outside air, delivering it to those zonal VRF units. And so you can come in on the plant level and modify details and really adjust the efficiency of your boiler or chiller or your dedicated outdoor air system, whatever heat recovery, whatever plant level mechanical system you may have there. In a similar fashion, I can jump down to the system level and jump into this office VRF pod. And again, a number of different options to select from in NEO for the different mechanical systems and conditioning types. So if I had heated only, cooling only, or unconditioned space, we've got a lot of flexibility to handle that. Multiple system types, fan coils, packaged single zone systems, constant volume, variable air volume, VRFs, heat pumps. Pretty traditional mechanical systems are all available for you to select from within here. If I go into the modified details, this is going to allow me to go down to that next level, define my efficiencies of my VRF units or my packaged rooftop units, whatever the case may be. NEO has kind of the smarts built into it here so that it knows which system I've selected, and it offers me inputs here that are appropriate to that particular system. And a great example of that here, I did define the office as having VRF, but the cafeteria, I just put a rooftop unit on, in part to show that NEO also has the capability to define multiple mechanical systems within the same building. That's very common, and you run into that all the time. And so we wanted to make sure that we've got the flexibility to assign a specific mechanical system to a specific area within the building and address it with efficiency measures as well. So if I jump from the VRF here, I'm going to do one of our kind of efficiency jumps here at the bottom. There's this button, jump to an HVAC system. If I jump over to the system serving the dining, now you can see I'm in the same pod in the same section, but now I've got those smart inputs. It's changed my view to offer me efficiency level inputs associated with a packaged unit as opposed to a VRF unit. So we jump back out of here, and you've now gone through and you've defined the VRF. Again, as a VRF or product manufacturer, you'd also want to define the other systems that you're comparing. We've got, so scenario B here is a packaged rooftop unit. So a very simple constant volume rooftop DX cooling and gas heat system. And then scenario C for comparison is a variable air volume system with a gas boiler and a water-cooled chiller. So those are the three systems that I'm going to compare while holding the rest of the building constant, lighting, building envelope, just to really kind of dial in and see the difference between those HVAC systems. Jumping to the third tab here, which is financials. This does allow the user to come in here and define the parameters of their study. You know, depending on the owner that you're speaking to, they may have a different appetite for, you know, how long their payback is and what kind of financial attributes of their building that they're looking at. And so in the general tab here, I'm able to come in and define the length of my life cycle cost analysis, as well as provide interest rates, utility, electric, gas, or district heating and cooling inflation rates, tax rates. If you're modeling projects that are international, tax rates can be very different for each of those specific locations. And similarly, we also get into, at the bottom here, I've got some location adjustments. So the tool does provide default costs as well to kind of help move this analysis forward. And so depending on where you're at in the country, the tool will use this mechanical, architectural, and electrical cost index. So if I were to take this model and move it to New York or California or Florida, these mechanical cost index values will go up and down accordingly to really try to match, you know, how much the price of living is in each of those locations. And what that feeds into then would be the individual HVAC system costs. So as I click on the VRF option here, I've got the central equipment again listed at the top and the system level equipment listed at the bottom. And each of those gives you an option to define first cost, maintenance cost, replacement cost, and equipment life. These are the default costs that are coming from that cost index on the previous tab. And it's using RS means to calculate those. That's a construction cost database. It's using RS means to help calculate these costs. If you are looking at this information and it doesn't seem to match or be in the ballpark of what you're hoping to have, you can simply come in here and manually edit these costs as you're speaking to your product manufacturer and you have that data available. So once you have all of the costing information determined in here, or you've reviewed the default cost and you feel that that's okay, we can click on the comparison tab here. And this is going to jump us over to the tab where now we're seeing the results of these energy models. DO2 is the simulation engine that NEO runs under the hood. It's an 8760 simulation engine. And so it's one of the most well-known energy modeling simulations that's out there. So, you're getting a good thermal and full building, whole building hourly calculation within the tool itself. Neo is really kind of the driver of the DO2 simulation. So you're working through the user interface, you hit calculate, and it goes and runs those models using the DO2 simulation and then returns those results here so that the building owner or user of the tool can come through and kind of filter and look at the different charts and see the performance of their building. Again, considering from the perspective of a product manufacturer here, if I'm a VRF salesperson, as I look at this, what this is showing is that the VRF system actually has a pretty comparable lifetime cost over 25 years as a packaged rooftop unit. So a building owner may just be looking at kind of the first cost of that rooftop unit and saying, wow, you know, it's pretty cheap. That's what I can afford. I'm going to purchase that, and you know, it's you know, energy efficiency out the window, right? But this, I think, makes a compelling argument that, hey, you may be, you know, paying more on your first cost, but ultimately you're saving on your utility cost and your maintenance cost over the life of the building over 25 years. It also shows you really kind of the difference here between a more expensive system. You know, you can ultimately spend less on your utility and less on your first cost than maybe, say, a traditional boiler and chiller system. So there's a number of different ways that you can look at this from a perspective of, you know, trying to make the case to find your system compared versus others. Kind of segmenting out the gray bar here, you can see a yellow, red, blue, and green dotted line. That's just really kind of a quick way to show what's making up that total cost. And so as we use the red one here, I think is a good example. The first cost of the VRF unit is slightly higher than this packaged rooftop unit. And you can see one thing that's really driving the VAV system to have the highest lifetime cost is that first cost. It's the highest. And so that slope is going up significantly there, indicating that it's got the highest first cost. We've got a number of other different ways in the tool itself to review the building's performance. So if I click on this chart type button here, I can come in and look at the savings summary and see which of these projects is saving the most compared to their ASHRAE baseline. I can also look at them from a relative savings perspective to see which is saving the most compared to each other. We've also got a number of different ways to look at how the building is using your utility dollars. So as a building owner, if I want to know where I'm spending or saving money, I can parse that information out here by seeing those dollars as they're attributed to things like heating, cooling, fans and pumps, interior equipment, and so on and so forth. And another one that I really like would be the electric consumption. One thing that we talk about a lot and is kind of a very important aspect of energy efficiency today is electrification. If you're, you know, considering looking at removing fossil fuels from your building, this tool can also look at things from an electricity and gas perspective so that you can see the effect of each of these mechanical systems from that perspective. So as we jump over to the gas consumption here, you can see that that VRF system is really using the least amount of gas of these three options. And that's really, again, that cafeteria had a rooftop unit that was using gas heat, whereas the office was electrically heated. So it drives down a significant portion of that gas usage that you're seeing in those other two systems. Two more things here that I'll show, Matt, and then I wanted to jump back over to that rating analysis mode, our other calculation. I had mentioned that the tool is using a DO2 simulation engine. One thing that we wanted to make sure to provide to our users was access to the raw modeling files. It's really nice to have an efficient, you know, modeling tool, but it's also great to be able to look kind of under the hood and really look at the simulation results themselves. And so there's all throughout our tools, there's options to get sim files. If I click on that and, for example, I click this sim files packaged rooftop unit, what that's going to do is it's going to run that simulation again and then actually send me a zip folder. And within that folder, it's going to have the input modeling file, so you can review all of the inputs of the model. And it's also going to give you the output, the simulation output file. You can open that up in any text editor like Notebook. There's a couple of other text editors that are out there, and really review the actual, kind of nuts and bolts and get under the hood of the tool. So we've made Neo, easy enough that really anybody can use it and navigate the tool with the automated inputs from the ASHRAE standards and IECC standards. while also having the option to kind of look at the more detailed view inputs from an input perspective and from the modeling files themselves. And so you can see this is just a quick download here and something that you can drop on your desktop. And when it's done, open that information up and look through the sim files and input files and see how your building is performing kind of underneath the hood. So I think that's kind of a nice output of the tool. And I will show you one other output, and then we'll jump over to the rating analysis. So if I jump out of the model and go back to the project navigator and scroll down to this HVAC lifecycle cost analysis, we've got a couple of options down here to come in and edit this particular project and analysis itself. Clicking on gears usually takes you into something that you can edit. So for example, here we've got the option to look at the different energy codes that I mentioned within the tool and select your analysis type and some other things as far as your utility data and whatnot. We also have the ability to create a report. So I just clicked on the report button. There's two deliverables that come out of here. One is a data export. If you don't like that text file and sim file, if that's a little bit too heavy for you, or you want to do some graphing on your own, you can export a Microsoft Excel workbook and use that to build off of for graphing and whatnot. Or if you've got a client meeting and you want to present this information and leave behind what you studied and the information that you talked about, you can click this results report button. What that's going to do is it's going to generate a Word document. And I would say in its kind of most basic form, I think we've tried to create a report that you could hand over to the client immediately. But we also made it in a Word document form so that the user can come in here and edit that, add their own logo, whatever, add a quote on the back of it, whatever they may want to do in order to edit that report and make it specific for their client. And so here is the HVAC report. You can see it took about 5 seconds to pull this out here. It's about 12 pages. It's got a quick executive summary to kind of hit some of the high-level information that's happening in that life cycle cost analysis, information about the model, where it's located, the weather file that it's using, what your ASHRAE baseline selection would be, a quick blurb about each one of those different HVAC systems that we've defined within the tool, and then really getting into a deeper dive of the analysis itself, talking about the life cycle cost analysis, the costs that we input on the financial page so that the user or building owner after the fact can come back, review that information and make sure that it's matching the costs that they would like to see for their project, as well as some of those simulation results that we saw in the visualizations area of the tool itself. So that's another output that we have. And then I mentioned early on that we've got another analysis, which is called our rating analysis. And so rating analysis here, I've actually got two examples of this. One for a new construction building and one for an existing building. As we look at our users, we oftentimes see architects and engineers that may be looking at working through new construction, design type of meetings, trying to help their clients and owners make early decisions and informed decisions to make a higher performance building. The new construction rating analysis is great for that. It's also something that you can use to go after lead. I know that you mentioned that we met at Greenbuild. We've actually partnered with the GVCI to provide more equitable energy modeling and using NEO to provide more access and equity with respect to affordable, validated energy modeling. So the rating analysis would be the tool within NEO that you would use in order to go after a LEED model or Green Globes model. AIA 2030 challenge, we've also got the ability in here to do an AIA 2030 calculation and upload. And then existing buildings, this would be more like a building owner, maybe an engineer that's looking at doing an audit or meeting a benchmarking ordinance. You've got the ability to actually put in your existing utility bills and perform an existing building model compared back to your utility bills. So kind of the difference there, new construction is going to compare back to your ASHRAE baseline. Existing is going to compare back to your existing condition baseline. As I jump into, we'll start with the new construction one here. Same kind of setup. I'm going to click on the launch analysis. This will go a little bit faster since we did some of the setup in the HVAC analysis, but it's really the same kind of first two steps where I'm defining the building and going through and inputting some of the information for operational schedules and those kind of things. In the HVAC tab for new construction, now we're really just looking at our proposed design. So this is kind of a refinement on your mechanical system. Maybe you've selected a system already, or you've done an HVAC lifecycle cost analysis and picked the most advantageous system for you. You can, again, kind of have that model evolve and bring it here to start looking at adding things like better controls or more efficient heat recovery or those kind of things. So again, you're defining your HVAC system here in this tab, and then jumping to the rating tab. This is where you're going to see the results of that rating model. A quick setup for the view here. Down below, these are the individual measures that you're considering for your project, and each one is a DO2 simulation with the results compared back to that ASHRAE code. So code may assume that you don't have a VFD on your heating pump and your hot water pump or your chilled water pump. So here we're running that baseline building, but adding a VFD on the hot water pump and comparing that result back again to the ASHRAE baseline. There's a lot of measures that we can look at. You can, add 10 measures or 100 measures, whatever the case may be. But within the tool here, you've got some functionality to look at this in a couple of different ways. I can click on the Add Strategies button. This is going to share all of the measures that are available for this building type and mechanical system that I've selected. So if I've picked a VRF or I've picked a chiller boiler, in an office or a warehouse, it's going to really try to steer those measures that are available to me to match each one of those different systems and building types. You can also see that we've got some design parameters that are available here. So, for example, I've got a condensing boiler. I could select a 95% efficient with an aggressive temperature reset, or if I wasn't looking at a condensing boiler, I could just simply select a regular gas boiler and put in an efficiency of 80% or whatever the case may be. Adding things like energy recovery, fan static controls, fan static levels, heat recovery, economizers, all of those things here are options that you can select and choose from for your project from a mechanical perspective. And just like mechanical, we've also got options for architectural, lighting, plug and process, and service water heating with the same setup. You've got the ability to come in here and add a measure, increase or decrease the efficiency of that measure to match your proposed design, and run that simulation against the code to see the individual measure savings. Once you've added the measures to this view, it then rolls all of that information up here at the top. So in this case, maybe I've got 20 or 30 measures selected. It takes all those measures, groups them into one final bundle of energy measures, and runs that again compared back to the baseline. And you can see here at the top, we're just seeing that whole building results as a result of that bundle. And so a lot of different metrics that we can use here to display that information. Again, this is something that is fully editable. So if you've got a specific client who's interested in looking at carbon emissions, maybe they're trying to follow a city ordinance and avoid a carbon tax, or maybe they're trying to get LEED points or AIA 2030 and kind of have an understanding for how they're performing against that standard, utility incentives. There's all kinds of options that we've got available in here to edit this view to really speak to your specific client. In this case, I just threw in an EUI, a couple of carbon values. This is the 2030 standard widget. So if I wanted to see how I was performing against the AIA 2030 standard, I come in here. You can see in this case that my design is not quite meeting the target. And so if I was really working to get to that target, I could come down here and add measures rerun them and in real time see that update and provide me with a comparison back to that value. And then over here, we've got some energy cost data. And just like the HVAC lifecycle cost analysis, we've got visualizations in here. So you can come in and compare and look at your building and see how it's performing. Whoops, apologize there. I'm gonna just move us out of the way. And see how you're performing, say, against the baseline for your particular project. So a lot of, again, ways to kind of view and see how your project is performing. Am I meeting, compliance for code or for the local codes? Am I meeting compliance for LEED or AA 2030? This is going to be the dashboard that's going to help get you there from that perspective. And then I would say, just like the HVAC analysis perspective or HVAC analysis, you can come in here, export your simulation files, and pull a results report that's specific to this analysis. It dives a little bit deeper into the measure level values, since this is kind of looking at your building from a different perspective than the HVAC lifecycle cost analysis.
All right, Eric, I really appreciate that presentation. I just had a couple questions for you. So as far as the user, you mentioned engineers, architects, and whatnot can use this. It seems like it's a great modeling tool for compliance, but more importantly, for the consumer that is going to use this, or if you're trying to justify this to investors, this looks like a sales tool. And it's like, so do you see that the engineer and the builder are trying to use this more? Like who's using this and who are they trying to sell to usually?
Sure. Yeah, I would say it can be a combination of a sales tool and a consulting tool, and really a calculator at your desk. Primarily users from a, well, I would say our general user base, again, are architects, engineers, product manufacturers, building owners, and utilities. That's really the core group, or core 5 of the user types that we see. And each of them use the different analyses that we covered today in kind of their own way. So product manufacturers really do use this primarily strictly as a sales tool. In some cases, they may also use it to help, provide incentives or rebates for, somebody purchasing their equipment. But at the end of the day, they're really using that HVAC lifecycle cost analysis, or this rating mode in the case of maybe a glazing, fenestration, or glass sales team, or something like that from a measure level perspective. But if we kind of just keep it on the HVAC level here, they really are using this as a sales tool to help make the case for their equipment over their competitors. Again, we've got the ability to customize the tool for those users to put in their specific efficiency curves and pricing and naming conventions and whatnot, so that they can really customize and tailor the tool to be used as a sales tool with their actual performance data input into the libraries themselves. So that's kind of one use case. I would say it's less of a sales tool for architects and engineers and building owners and utilities. For architects and engineers, it's really more used as a consulting tool, helping their building owners and their clients make better decisions, reach energy goals, reach budgetary goals, and those kind of things. Building owners, the primary use that we see for folks who have either a developer or a building management program, or just somebody who, for whatever reason, owns a large stock of buildings. They're typically using it to make sure that their existing building stock is operating well. In that existing building rating analysis, you can look at both capital measures and operational measures. So if you aren't doing nighttime temperature setbacks, or your outside air is out of whack within your building, you can look at some operational measures as well too, to make sure that you're most optimally driving your building. And then from a utility perspective, again, not necessarily a sales tool as much as it's used to gain incentives or show compliance for electrification. So in those cases, oftentimes they'll have either folks from the utility that are technical in nature helping trade allies and building owners achieve incentives, or in some cases, we've even seen utilities that have the tool and then kind of open it up to trade allies to come in and use it, so they can run models and submit those for incentives and rebates as well. So it definitely can be used as a sales tool, but it also has a lot of consulting uses as well.
Thanks again, Eric, for this wonderful presentation and demonstrating how your tool works so we can optimize buildings to make them super energy efficient and also understand the paybacks. If you guys enjoyed this video, give us a thumbs up and be sure to hit the subscribe button and click the bell for notifications so you can see all of the new exciting videos that we have coming up in the near future. Thanks again for watching this. I want to see you guys next time.